Hi guys, we're going to go ahead and start today with talking about transformations that data can go through, okay, and how that affects that measure of center and spread. Okay, so we know that measuring the center, whether that's mean or median, and then measuring how varied the data is an important idea. Well, what happens if, something in the world goes on and it takes our data and it changes out every single one of those pieces of data in a certain way. So maybe you give everybody $1,000 raise, or you give everybody a certain percent raise, or whatever. Then you would know what that new average and new standard deviation is just by knowing what we're going to learn today. All right, so here's our data. And the first thing that we're going to do is we're going to use our calculator um, to learn how to quickly compute this information. So the first thing I want you to do is get out your TI calculator and go into your stat edit, okay, and put this data into your L1. Okay, and if at any time you need time to do that, go get your calculator or whatever, pause this video so that you have time to do those things, because I'm going to keep going as if you've had time to enter in all the data. All right, so we have our data put into list 1. All of these quiz grades that are for the AP Statistics class out of 40 points. All right, so we put our data and we're going to determine the shape of that distribution. Okay, so I'll show you how we can do that in the calculator. Okay, so I hadn't talked to you kind of about how to see graphical representations. But there's various ones we can see. So we're going to come over here and we're going to go turn a stat plot on in our calculator. So second y equals, okay? So second y equals, and then I have these options, okay? And so I have data here in or I have this information here. I'm going to hit enter, and then I'm going to, yours just defaults to off. So you put your cursor here and turn it on. All right. Then you have different types of graphs you can do. Interestingly enough, so this is a dot plot or a scatter plot. This would connect those dots. Here's a histogram. This third one is a histogram. Now, you could actually compute the box plot with outliers. This is a modified box plot that will show outliers. This one beside it would not show the outliers. All right, so let's just look at the histogram. Since we know box plots will not give us a mode, okay? So let's look at that histogram. Now, the data that I have is located in list 1, not list 2. So the way you put an L1 right here is you go second and then L1, okay? We're going to just leave the frequency the same, and now we're ready to graph. But if you hit graph, then it won't necessarily give you the correct window for your statistics you put in. So instead of hitting straight graph, we always hit zoom. And then if you look at number 9 down here, it's called zoom stat. Zoom stat will let the calculator automatically make a window for the statistics that you have put into the calculator and that you are graphing. So zoom 9. Okay, so I have an error. Let's go investigate. So let's see here. Oh, okay, it's probably because I have 2 plots that are about to graph the same thing. So let me go ahead and turn this second one off. That would be my guess. So let me try that again. Zoom 9. Nope. Okay. Check. Well, there you go. So if you're having an error, then we've got to investigate what that error is. Quit. Now, FYI, if the error screen ever comes up to go to, GOTO, then I usually do that. I go to, oh, look, whenever I did that on this, I turned it off. Oh, I know why. Because I also have something on plot 3. I have plot 3 trying to graph something, and there's nothing in L3. Okay, so I know why. See, something in L1, and I'm turned that plot on. Something in L2, this second plot is off because I don't want to graph two things on L1. But look at what happens here. See this third one? Um, L3, and I didn't have anything in my list 3, so I'm going to turn that one off also. So it was trying to graph something that it did not have a list of. All right, so now here we go. There it is. Okay, so there is our data, and it kind of makes the bin size automatically, and I'm not going to go through that. But you can see here, I dragged that picture, and so here is the shape of our distribution. Okay, now let's move on. So now I decide that the quiz should be weighted as 50 points. So I'm going to add 10 points to each score. So let's do that. Instead of retyping the data, we can actually go to our list and do a function. Now, so here I am on L2. I am going to move up. Okay, do you see this so that I put the cursor on L2? So there is the cursor on L2. If you try to do what I'm about to do while your cursor is down here in the list, it will not work. You have to put it on top of this L2. All right, so I have this on top of L2. And so now I'm going to make the function for this. See here down here, I'm going to command the function second 1 for L1 plus 10. Okay, so I'm commanding it to do that. And then it will just automatically add 10, and I don't have to do that. All right, so let's take a look at how that changes the data. We're going to come on down here. Oh, you know what? I forgot to do all of these data values for our original information. So just FYI, when I went to Stat, Calculate, the one variable statistics. Oh, see, look here. I want to make sure I'm doing it for list 1. So second 1. Okay. Now that gives me everything. See, this X bar is 30.2. That's the mean. S of X is the standard deviation for our sample. So I put that there, not the sigma, because this is a sample, not the whole population. And then here's our 5-number summary. Okay, so I put all of that data in here, and this is somewhat symmetric. Okay, now we want to get the data, we want to get all of these things for list 2. So in here, I'm going to calculate all of that information for list 2. So I'm going to go Stat, over to Calc, one variable Stats. Now, if you have a calculator that does not have this little menu that pops up, it always defaults to list 1. So in order for it to make something else other than calculating on list 1, you have to tell it to calculate on list 2. And that's what we want to do. So again, yours looks like one variable stats, and then you put next to, then you type in second L2, and then it will calculate the one variable stats on list 2. If you do not, then it's still going to give you the data, the statistics for list 1. So if your information looks the same as this original data, you did not type that in properly. So here's this. Now, I'm not going to show you the picture. Well, I guess I could show you that picture real quick. If I go into Stat Plot, I want to turn on this second one. And I can show you, I'm going to turn it on, and I'm going to make it graph L2. Zoom 9, zoom stat. So what happens is, look, it shifted the data up 10. And we see that with our values. It just took everything and shifted the measures of position up. So look at what I have highlighted in purple here. These are measures of location, measures of position. Also, your measures of center, mean, and median. Those were affected by adding 10. But look at what I have here in yellow. The spread, IQR, standard deviation, and range did not change. You see? It just shifted up 10. Okay. Now, let's go do the next thing. The next one says, instead, I think I might weight it as 80 points. So I double each original score. In the calculator, go to the top of L3 and hit L1 times 2. So here we go. Going to go to the top of L3. Remember that you have to put the cursor on top of the L3. And I'm going to command it to do list 1 times 2. Okay? So that takes all these L1s and it doubles them all. All right. So let's now calculate the statistics for list 3. Stat, over to calc. That's one variable stats. Do I want L2 here? No. So even if you have a calculator that doesn't show up this menu, you need to type second 3 so that it'll compute the one variable statistics for list 3. And then here we go. So look at these values. We're going to move on over and record how all of these values changed. So let's take a look. This red one, 2 here, doubled. So all of the measures of position that I have highlighted here in purple doubled. So everything doubled. But look at what else doubled. The standard deviation, the IQR, and the range also doubled. Okay? Now, I have another visual to help you with this. So let me get it and show you. Okay. If you think of this as your data, okay, so if we think of this is all the collection of data. When you add 10, it shifts the data. Oh, wait, here, I want to go make it bigger for you. When you add 10, it shifts all the data up 10. So everything increased by 10, but the spread did not change. But if I take this information and I double it, watch what happens. Okay, I doubled it. So all the center, everything is doubled, including how spread out the data is. So we're going to see that shifting is affecting the measures of position, but not the spread. Okay? Multiplying is dilating it, and it's multiplying everything by 2, including how spread out the data is. So that's what's happening. All right, let's just test that theory and go forward. Here we have. Instead, I think the quiz should be out of 100 points. So I'm not only going to double it, I'm going to also add 20. So here we have our original data. I'm going to double it and then add 20. So that shift is going to be, so I'm going to double it first and then add 20. So that adding 20 did not affect, we want to see, does it affect the spread? What does it affect? Okay, so you're going to come in here. Let's do this one last time. Stat calc over to L4 and put your cursor on top of the L4. And we're going to command it to do list 1 times 2. Okay, and then add 20. All right, so that equals that value right there. Okay, so let's calculate. Stat, calculate the one variable stats of list 4. So second, L4. And then we calculate, and you can see what happened to the mean, standard deviation, and all of those items. You can go down, and here it is. So you see here, look at this yellow column. From multiplying by 2 to multiplying by 2 and adding 20, it did not change the spread, the IQR, or the range. So standard deviation, IQR, and range was not affected by addition. It was only affected by this multiplication change. All right. So again, the purple areas are measures of position. The yellow areas are measures of spread. So I want you to answer the following questions. How has the general shape of the distribution changed in the four situations? So the symmetry and the unimodal, how did that stay? The entire time it stayed. So see, the shape of this isn't changing. It's still circular. All right. Compare the means and the medians for the four situations. The means and the medians. Okay. So they all went through the same thing. So this was a little bit somewhat symmetric. Yeah, 30.2 and 30. And look, 40.2 and 40, 60.4 and 60, 80.4 and 80. So it stayed somewhat symmetric that whole time because the mean and the median were approximately the same. They both increased by 10. They both got 2 times larger. They both doubled and got 20 larger. But look here. If I added 5 points and then found the percentage out of 40, then let's talk about how that would have happened. Adding 5 points would shift the data up 5, affecting the measure of position only. Okay? But when you then divide by 40, however, that dividing by 40 would be like you starting stretched out and you're going to divide by 40. You're going to compress it. So that is something similar to the multiplication or division, which that would compress the data or shrink it. So then, of course, that would affect those measures of position. It would affect where all the Q1 and median and all of those are located. But that compression also affects the spread. All right. Next page questions. Now we're going to talk about the measures of spread, standard deviations. Compare the standard deviation, the IQR, and the range for the four situations. And we've talked about this as we went along. When we added 10, those measures of spread stayed the same. When we multiplied by 2, the spreads also doubled. When we multiplied by 2 and added 20, the spreads only doubled. The addition of 20 did not change the spread. If we added the 5 points and then divide by 40, again, I just copied this statement from previous page. The adding 5 does not affect the spread, but the dividing by 40 does. All right. So, in general, what happens to the summary statistic if every data value in the set is multiplied by a constant? For every multiplication by a constant, we get A times bigger for all of these statistics. The center, the spread, and the quartiles location are A times bigger. But in general, if we added a constant to every piece of data set, then what happens? The mean and the median increase or shift by B, either up B or down B. Quartile, also a measure of position, shifts and increases or decreases up B. The standard deviation would not change and the IQR would not change because there's no change in spread. All right, so in summary, adding a constant changes Mean, median, and quartiles, the measures of position. Adding changes those. Multiplying changes everything. They are both measures of center and spread. All right. So what would happen if I multiply each, I have a set of data, and I multiply the set of data, okay? I multiply it by 4, and then I add 6. What's going to happen? Well, here's an example. The mean gets multiplied by 4 and added 6. The median gets multiplied by 4 and added 6. But the standard deviation and IQR only multiplied by 4. No adding the 6. All right. So that's the end of the summary of what happens to our transformations or what happens to our measures of our statistics, particularly center and spread, how they are affected by multiplication and addition, or multiplication division, okay, and then adding and subtracting. All right, I hope that clears up how transformations affect measures of center and spread.